So now we're doing TryHackMe Pre-Security Linux Fundamentals Part 3, Task 5, Processes 101. All right, let's open up the show split view of the attack box. And also before we go, get into it. Hold on. All right, there it is. Before we get into it, I started this fundraiser on GoFundMe because ChatGPT 5's $200 and I just can't afford it right now, so I'm gonna have to reach out to you guys. So if I'll leave a link in the description if you're interested in it. Check it out, please. That being said, here we go. So processes are the programs that are running on our machine. They're managed by the kernel, where each process will have an ID associated with it, also known as its PID, or process identification, right? The PID increments for the order in which the process starts. For example, the 60th process will have a PID of 60, all right? We'll see what that means in a second. So here's viewing processes. We can use the friendly PS command to provide a list of the running processes as our user's session and some additional information such as its status code, the session that's running it, and how much usage time of the CPUs it's using, and the name of the actual program or command that's being executed, all right? So we've got this right here. We're doing this. We're saying PS right here, like we set up here, and this is process 204. And then when we do it again, it says process 205. This doesn't really make sense, and it pretty much just says what I just said. To see the processes run by other users and those that don't run from a session, i.e. system processes, we need to provide aux to the PS command like so. So PS aux. So right here, let's do PS right there. We can see this was 1069, and if we do it again, PS, it's 1070. We do it again. That's nothing. That's nothing also. And we got, and so it just keeps on going. I don't know what's going on in the background to where it skips so many times. We do it again, and we can see, I don't know. Honestly, I don't know what's going on. That being said, that's basically what's happening. Clear this out. And so when we do the PS aux, we get to see everything that's going on. Remember this THM processes. We're going to need to remember that later. Anyway, so note we can see a total of 5 processes. And also note how we now have root in CMNATIC, cinematic. I don't know what that is. Anyway, so we have these here instead of just the PIDs. It has the usernames as well, right? So I guess that's the name of the guy that wrote this thing. So another useful command is the top command. So top gives us real-time statistics about the processes running on our system instead of a one-time view. These statistics will refresh every 10 seconds, but will also refresh when we use the arrow keys to browse various rows. Another great command to gain insight into our system is via the top command, all right? Just to repeat itself. Let's do top over here, and we can see it does all this stuff. And when we go down like that, it refreshes stuff up here. You can see it's refreshing up in this thing right here. And so pretty much the top command is the same as doing like Control Alt Delete and looking at the task manager, but a little bit different. All right. So let's look at managing processes. We can send signals that terminate processes. There are a variety of types of signals that correlate to exactly how cleanly the process is dealt with by the kernel. To kill a command, we can use the appropriately named kill command and the associated PID that we wish to kill, i.e. to kill PID leet, L-E-E-T, right? We use kill leet. Okay. Let's get out of this while we're here and then clear this out. Below are some of the signals that we can send to a process when it's killed. We got sigterm, which kills the process but allows it to do some cleanup tasks beforehand. Sigkill, this kills the process. It doesn't do any cleanup after the fact. And then sigstop stops or suspends a process. All right. So how do processes start? We're going to start off by talking about namespaces. The operating system, or OS, uses namespaces to ultimately split up the resources available on the computer, such as CPU, RAM, and priority processes, just like we saw in the task manager, right? Think of it as splitting our computer up into slices similar to a cake. Processes within that slice will have access to certain amounts of computing power. However, it will be a small portion of what's actually available to every process overall, unless, of course, you're making videos and then it's going to take everything it's got. So namespaces are great for security as it's a way of isolating processes from another, right? Only those that are in the same namespace will be able to see each other, okay? We previously talked about how PID works, and this is where it comes into play. The process with an ID of 0 is a process that is started when the system boots. This process is the system's init on Ubuntu, so initialization, such as systemd, which is used to provide a way of managing a user's processes and sits between the operating system and the user. Okay, I'm sure this is all stuff we need to know for hacking, all right? For example, once a system boots and it initializes, systemd is one of the first processes that is started, right? Any program or piece of software that we want to use, that we want to start, will start as what is known as a child process of systemd, okay? So this means that it's controlled by systemd, but will run as its own process, although sharing the resources from systemd to make it easier for us to identify and the likes. Okay, let's do aux. Let's do ps aux over here. And we can see it doesn't really have any systemds. If we go through, it just has roots and syslogs and stuff like that. But whatever, we'll hopefully we'll figure this stuff out later. Let's clear this out. So getting processes or services to start on boot. Some applications can be started on the boot of the system that we own. For example, web servers, database servers, or file transfer servers, all right? This software is often critical and is often told to start during the boot up of the system by administrators. In this example, we're going to be telling the Apache web server to start Apache manually and then telling the system to launch Apache 2 on boot. So this is where the use of systemctl comes in. This command allows us to interact with the systemd process or daemon, all right? If you're a religious type like me, and you look up who made Ubuntu, you'll understand why he used this, because he's a bald nerd. Continuing on with our example, systemctl is an easy to use command that takes the following formatting: systemctl option service, all right? For example, to tell Apache to start up, we use systemctl start Apache 2, all right? Seems simple enough, right? Of course. Same with if we wanted to stop Apache, we would replace option with stop instead of start like we provided. And we can do 4 options with systemctl, all right? So also, if we go to the man page for this thing, there's a lot more systemctl. There's actually a lot more options than that. We've got stuff like this. We've got this, we've got this, we've got this, there's like so many different things other than these 4 things. So it is what it is. Let's queue to get out of that and then clear this out. So we've got the 4 options: start, stop, enable, and disable. So an introduction. So now we're on to an introduction to backgrounding and foregrounding in Linux. Processes can run in 2 states, in the background and in the foreground. For example, commands that we run in our terminal, such as echo or things of that sort, will run in the foreground of our terminal, as it's the only command provided that hasn't been told to run in the background. Okay. Echo is a great example of the output, as the output of echo will return to us in the foreground. Okay, of course it will, but wouldn't in the background. And then let's look at the screenshot below, for example. So we've got echo high HTM, so it does this, and then echo high HTM and this right here. I forgot what the and operator does, but whatever. And so now when we do high HTM, it does nothing. I guess it runs this in the background. I honestly have no idea what's going on right here. So we're running echo high HCM where we expect the output to be returned to us like it is at the start. So that's this part right here. But after adding the AND operator to the command, we're instead just given the ID of the echo process rather than the actual output. So I guess this isn't even part of this. This is just high THM and then the AND, we press enter and we get this stuff. All right. Blah, blah. So as it is running in the background, I don't know what this part's about. So whatever. So this is great for commands such as copying files because it means that we can run the command in the background and continue on with. So does this run it in the background if we push and next to it? I guess that's the point of this. If we put and next to whatever we're doing, it'll run it in the background. So if we say hi THM, we can see that it is actually running. Let's actually do that. All right, let's try that out. Echo. And then let's just say hi, doesn't matter. And then it does that. And then let's do echo hi, and then do the and sign, which is right here. All right. Okay. So that's what's happening. It's running this thing in the background. So I guess we would do a control Z, control V, control Z. Well, that's good enough. All right. And then let's clear this out. Boom. All right. So blah, blah, blah. So we can do the exact same when executing things like scripts. Rather than relying on the AND operator, we can use Control Z on our keyboard to background the process. It's also an effective way of pausing the execution of a script or command like in the one below, right? So let's actually grab a script. Actually, let's let's open a brand new tab that's in this root thing. And then let's come over here. I've got a script made up for us right here. And then we'll just drop this in with the Control Shift V. So while true, we're going to do echo hello world, and then we're going to sleep one and done. Right? This sleep one means it's going to pause 1 second between each hello world, and it's just going to keep going while it's true. All right. So when we press enter, hello world, hello world, hello world, and then when we press Control Z, it stops it like that. Now the thing is, if we come over here and we don't have sleep one in it, it's going to go forever. If we press Control Z, it's not going to do. Look at this. Look at this. It's going crazy right now. So we got to get rid of this just like that. And that's what happens if you don't have that sleep in there. I just let you know. So that script's going to keep on repeating. This will keep looping until I stop, until we do Control Z. All right. And that's basically what's happening right here. So now the terminal, so now our terminal is no longer filled up with messages until we foreground it, which we will discuss below, right? And also, if you do that, that's why you want to do open it in a new tab, because you're going to have to re-log into TryHackMe if you do it over here, right? Just letting you know. So foregrounding a process. So now that we have a process running in the background, for example, our script background.sh, I think that's this thing right here, which can be confirmed by using the ps-aux command, we can backpedal and bring this process back to the foreground to interact with it. Okay. With our process backgrounded using either Control Z or the AND operator, we can use the FG to bring. Oh, let's try that. Let's open it over here though. Open tab. We can use FG to bring this back into focus like below, where we can see the FG command is being used to bring the background process back into use on the terminal, where the output of the script is now returned. Okay, so now let's do the script. Let's grab this thing here. All right, let's do a Control Shift V over here, and then let's do an AND. All right. What? That didn't work. What if we do FG? Okay, whatever. All right, Control Z. All right, whatever. So I don't know what this thing's talking about, and I don't really know how to make that not do that. But whatever. Anyway, so that's what that says, and now we're on to the questions. So README, we already did that. If we were to launch a process where the previous ID was 300, what would the ID of this new process be 301 by process of adding 1 to it, right? Yes. If we wanted to cleanly kill a process, what signal would we send it? Cleanly kill it. Cleanly kill it. Let's go back up here because I forgot. Kill the process, but allow it to do some cleanup tasks beforehand. Let's grab this. Let's come back down here. Let's see if this works. Looks like it fits. And there we go. So locate the process that's running on the deployed instance. All right. So I already forgot what it was, like THM something. So let's do, what was it? PS aux. And then we saw that it was up here somewhere. Tell me if you see it. I think that's too high. Let's go back down. THM process. All right, here's that. Let's go like this. Do Control Shift C. I hope that works. Control V over here. Ah, awesome. So Control Shift C will copy from the terminal. Submit it. Come on now. All right, so what command would we use to stop the service, my service? Stop the service, my service. Let's go. It's something, it's that thing with the stop and then my service for sure. All right, let's go over here. Not here. Where it was talking about, not these. Not these. Here we go. Systemctl. Stop. And then whatever. So let's do that. Systemctl space stop space my service. Submit it. All right, great. What command will we use to start the same service on the boot of the system? Systemctl, and it can't be start. So it's got to be that enable one. Enable. And then my service. All right, let's submit it. All right, there we go. So what command will we use to bring a previously foregrounded process to the foreground, backgrounded thing for the foreground? We use this FG. So let's do that. FG. And submit it. All right, there we go. All right, get out of here. So now we're on to task 6, maintaining your system automation. And we'll see you next time.